So we have the example where we're considering the proposal for an investment where we invest 11,000 Rand now and in 3 years' time get 18,000 Rand return. And alternatively, the money could be invested in the bank at 12% per annum effective. So we're first just going to look at the investment option where we invest 11,000 Rand now and in 3 years we get 18,000 Rand return. So let's just write it as a timeline quick so we can see what's happening. So at T0, we put in 11,000, so it's an outflow of money from us. And then we have T1 occurs, T2 occurs, and then at the third one, T3, so in 3 years, we get 18,000 Rand back. So it's an inflow of money to us. Now, what we try to do with the net present value is, remember, we are trying to look at what would we have to put into the bank to get the same return. So to get the return of 18,000 Rand. So what we're going to do first is we actually going to see, okay, if we had to put this into the bank, what would the PV be that we would put into the bank? And then we're going to compare what we would put into the bank, so that the PV that we put into the bank, with the PV that we put into the investment. So let's go through and work out how much would we have to have put into the bank to get that 18,000 Rand future value out. So we just use the normal, compound interest formula. Future value is equal to the present value, 1 plus IM to the power of N. And in this case, we want to find PV, so make PV the subject of the formula. So it's just PV is equal to the future value, 1 plus IM to the N. And in this example, we're not putting in money in a bunch of different areas. So this is just going to be one calculation for us to work out the present value. So it's a duration of 3 years. So our N is equal to 3. Let's just write that down there. Our effective interest, our I1, is equal to 12%, which is equal to 0.12. And our future value is the 18,000. So if we did this via our formula, we'd be 18,000, 1 plus 0.12, and 3. And that is going to give us a present value of 12,812 Rand and 4 cents. So to get the same money out from investing in the bank, we would have had to put in 12,812 Rand and 4 cents. Whereas if we invest in this other investment, we only have to put down 11,000. So if you were looking at it as an investor, you would obviously prefer to put down a lower investment amount. So, you're risking less money kind of thing. And therefore you would go for the project. Let's refer to the investment as a project and then the bank option. So that's why when you just look at them and you just make a comparison, you'll compare you would put in 11,000 in your investment to get to the 18,000. To get 18,000 from the bank, you would have to put in 12,812 Rand. So that's what the net present value is actually going to be doing for us. It's going to be doing this calculation and working it out in the background for us and giving us the answer. And it's going to give us the answer via the net present value, which is a formula. And the formula is NPV. Let's just write this down. NPV is equal to the PV returns minus the PV, where the PV returns is the one from the bank. So how much we would need to invest in the bank to get the same return as the investment. And then the PV itself, that's the one from the investment. So that's the one from the investment or project. And once again, the returns is what you put into the bank to get the same future value out. And if you have it like that, what you're going to notice is, for our example here, we'll have 12,812 Rand and 4 cents minus the 11,000, and it's going to give us 1,812 Rand and 4 cents. And what we see here is that if the net present value is positive, so if the NPV is greater than 0, then we are going to want to invest in the investment or project. Why? Because what this is telling us, it's telling us that we would have to invest an additional 1,812 Rand in the bank to get the same outcome if we had to invest in the project. So to get the same future value if we invested in the project. So once again, just repeating myself here, the NPV is equal to the PV returns, and that's the present value that you would have to invest in the bank to get the same return as your investment or your project's investment, minus the present value of the project. And that, so therefore, if it's greater than 0, we would want to rather invest in the project because we can invest less in the project to get the same, financial future value coming out. So in this case, we can invest 11,000 in the project and we get 18,000 Rand coming out. Whereas to invest in the bank, we have to invest 12,812 Rand and 4 cents to get 18,000 Rand out. So the NPV, if it's greater than 0, you invest in your project. If it is less than 0, you would prefer to invest in the bank because then you're investing less in the bank to get the same outcome. And if it's equal to 0, you can just choose whichever one you're comfortable with. Okay, so NPV, this is the background information of it. Your calculator does all the working out for you. And this is useful, particularly when we start adding in extra pieces to it. So in this example, you just had one, you put down one set of money and you got one set of money out. But in real life with projects and investments and stuff, you may have to put down like 10,000 Rand in year 1 and 10,000 Rand in year 2, and then you start getting 5,000 Rand back every single year for like 5 years or something. That is going to be harder to work out individually in these little like pieces of working out than if you had to just use your calculator. So your calculator is going to do all that background working out for us. So let's first just introduce how to put it into our calculator for this simple example before we move on to, a more challenging example to point out, again, why you're so interested in using your financial calculator instead of doing it all by hand with your formulas. So for our financial calculator, we're going to be interested in this little timeline. So what we're going to do is we're just going to find a clean piece of screen and we're just going to write down the timeline quick. So let's just move it like that. And our timeline is, we have T0 and we have T3. And then we have the minus 11,000, not 10,000. And then we have the 18,000. Next up, we're just going to fill in all the time periods between T0 and T3 because when we put it into a financial calculator, we actually have to put in data for every single time period so that it can go ahead and do the calculations for us. So we're going to need, the T1 and the T2. And in this case, we don't put in any money and we don't take out any money at T1 and T2. So right now we actually have like a table of values, and at T0, we have minus 11,000. Then at 1, we have 0. And at 2, we have 0. And at 3, we have 18,000. And we actually going to put this kind of like table into our financial calculator. the buttons of interest are going to be the CFI button. So the CFI button is going to be our button of interest for this. So what we're going to do is we're first going to, as usual, clear our information. So the first thing, whenever we use our financial calculator, we do that second function, CA. So that's still normal. We are going to have to consider adding in just an additional piece of information here to clear the kind of information that we're putting in the data in this table. And that's going to be the CFI and then second function, CA. So that's going to clear, our table data values. Then what we're going to do is, so now we're going to put in all our data. So of this table that we were just discussing now, we're going to put that into our calculator. And we're going to do that by just going through the process and saying our first entry is negative 11,000. So we're going to go plus minus the button 11,000. And then we're just going to push enter. So it's going to put it into data, much like we put things into data before. Then we have our next one is just 0. So we're going to say 0 and enter. Then 0 and enter. And I will discuss a trick regarding repeated values in the next example. So there is a shortcut that we can use when we have repeated values. And then we have the 18,000 and enter. So to put that in, we're going to have to push the second function and the CFI to bring up the cash, basically, because we want to use the cash feature. And it will say rate IY on your screen. And then we're going to put in the annual effective interest that the bank investment offers for us. So that in this case is going to be 12 because it gave it to us as 12% per annum effective. So we're going to type in 12 and then we're just going to push enter. And now we're going to push down because you can see in the corner, there's an arrow to show you that there's menu options. So much like when we had PY and CY, we're going to do a very similar thing here. We're going to push down and it's going to display the net PV is equal to 0. And what we're going to do now is when it says net PV, we're going to ask it to compute. So we're just going to push the compute button and it's going to update our net PV value. So we're going to be like compute. And that's going to give us our net PV equals to 1812.04. So the process for our net PV is we first do our clearing of our memory. So we do the standard one that we used to. Data tables. So that's all in stage 1, just the clearing of the memory so we don't introduce artifacts from previous calculations. Then stage 2 in this case is inputting the data tables. And once we've finished inputting the data table information, we then bring up our IY menu and our PV menu. If we have the effective interest rate, and we want to compare using the net PV, we put in the bank's interest rate by replacing the rate IY with a value. In this case, it was the bank's effective interest rate, which is 12, and we enter it. And then we push down and we see net PV. The net PV is currently sitting at equals to 0. We ask it to compute the new net PV. And then it does, and it gives the net PV to us. And then we have our answer. Okay, so let's just move the page a bit so we can see how we do it on our calculator. Okay, so we want to work out net present value with our calculator. Now, before we go ahead and put in our data, we need to make sure that we've cleared all our information on our calculator. So we have the second function, CA. That's going to clear the things like the rates and the compound interest and all that kind of stuff. But if we push CFI right now, we can see there is information sitting in the background of our calculator. It's stored back there. And that's like our data table. And that's the data table that we're actually going to be inputting now. So how do we clear this data table out so that we make sure there's no artifacts from previous calculations affecting our current calculation? Well, all we're going to do is we're going to push that CFI like we just did. Let me just start it from fresh. So CFI, second function, CA. And now it's going to clear that up. So if we push CFI now, you see nothing's going to show. So that's how we're going to clear our data tables in relation to our net PV so that we don't have any artifacts from previous calculations. Then we also have the second function, CA, that clears the normal stuff for us. Now we're going to put in our data table. So we have two options on how we can put it in. We can put it in, time period by time period. So T1, T2, T3, T4. But we usually start at T0. And our calculator will also count it from 0 onwards. So T0 from our timeline, that was minus 11,000 because we're going to invest that. So it's an outflow of money from us. So we have minus 11,000. We type it in and then we're just going to push enter. So we're just going to store it. So now it's stored where I is equal to 0 basically. So at T0, that's what that 0 means. Then we're going to store the next time period, which is T1, which is currently just 0. So we say 0, enter. The next time period is also 0, so 0, enter. Then the third time period is 18,000 and it's positive. So it's what we're going to get returned to us. So it's an inflow of money to us. So we have the 18,000 and we push enter. Now we have all our data in the table. So now we can actually go ahead and put in the interest, so the alternative. So we have the project information, it goes in via a table. And now we're going to put in, like if we just invested in the bank, what interest rate percentage we would get via that. So we will push second function and CFI to bring up the cash button. And then we see rate IY shows up there. So now we can input the nominal interest rate of the bank's option. So it was 12% per annum effective, which is also 12% per annum compounded annually. It's our nominal interest rate. So we can put in 12 and push enter. Now you can see there's an option to scroll down. We're going to scroll down. So we're going to scroll down until we see net PV, and then we're just going to ask the calculator to compute it for us. So compute. And now we get 1812.04. So this is telling us that the project will give us more profit than if we had to put it into the bank. So we get a greater return if we had to use the project versus if we had to put it into the bank. In other words, and remember this net PV is actually saying, it's saying that to get an equivalent future value out of your investment, you would have to invest an additional 1,812 Rand and 4 cents at the beginning into the bank. So you would have to invest more in the bank in order to get the same return that you would get from your project. Okay, so in this example, we're just going to use the financial calculator to do the working out, but we're going to go through the process again. So consider the following proposal for an investment. Invest 10,000 Rand now and in 3 years get 16,000 Rand return. The money could be invested at the bank for 18% per annum effective. So we're lucky in the fact that it gives us the per annum effective of the bank. Because remember, when we put in this into our financial calculator, we have to put it in as IY in percent. So we have it already as IY in percent. If it was not as IY in percent, we would have to make that conversion before we can input it into our calculator. Next up, let's just look at the timeline. You don't have to draw the timeline. I'm doing it just so you have a visual understanding of what's going on. So when you have more complicated questions, you can see what to do. So T0, and in 3 years' time, T3. So T0, we invest 10,000, so it's minus 10,000 because there's an outflow of money from us to the investment. And in 3 years' time, we get 16,000. So it's a positive value. It's an inflow of money to us. And then at T1, we don't do anything, so it's a 0. And at T2, we don't do anything, so it's a 0. There will be questions where, again, we will have a situation where we'll invest, say, 10,000 Rand every year, or we'll get 5,000 Rand back every year, or 5,000 Rand in 2 years and 20,000 in 3 years, and so on. So this can get more complicated. This gives us the data table. The data table is 0, has that minus 10,000. 1 is 0, 2 is 0, and 3 is the 16,000. So you could draw it as a timeline, or you could just draw it as a data table. Now, in our financial calculator, we are going to, step 1, always clear everything. So we're going to have second function, CA, and then we're going to clear our data tables from the previous questions. So that's CFI, second function, CA. So like all things in our financial calculator, we just clear information from previous calculations. Then stage 2, we're going to put in information. So the first one is the minus 10,000. And we have to do this in order. So minus 10,000, enter. Then we have a 0 and a 0. So there's a repeat. So what we can do is we can actually put this in as a data set. So we can actually say 0 and then use the XY button to pair it with data and say, well, it features twice. So we say 2. So if it featured 3 times, we would say 3. If it featured 5 times, you would say 4. So we put the number first, then we push the XY button, and then we say how many times it's duplicated. And it must obviously be in order. So if you have 0 happening later on, you'd have to input 0 again later on. So when you put this in, it must be in order. And then we push enter. And the last one that we put in is 16,000. And enter. So just a reminder about the part over here with the 0 and 0. You could have said 0, enter, and 0, enter. So you could have done it the long way, but it's going to be useful for you to understand the trick when you have duplicates to speed it up when you have more complicated questions. So we've inputted our data now. So our next stage is we're going to input the annual effective interest rate of the bank so that we can make the comparison and get the net PV. So to do that, we're going to say second function, it would be useful if I actually wrote this, second function, CFI, and it's going to bring up that menu, and it's going to show the rate IY, and we're going to update it to the effective interest rate displayed here, the I1 value in percentage. So that's going to be 18, and we're going to say enter. Then we're going to push down so that we can see the net PV is equal to 0 showing. And then we're going to ask it to update that. So then we're going to say compute. And then it's going to give us a net PV of minus 261.91. So what that is saying, it's saying that we invest less in the bank to get the same amount of money that we would invest in the project. So we would actually want to reject the project and accept the bank. So we reject the project or the investment as the NPV is less than 0. So a reminder about that, the reason why we do that is your NPV is equal to your PV return minus your PV, where your PV is from your investment and your PV return, it's what you would invest in the bank to get the same value out as you would your project. So in the end, if it's negative, it means you have to invest more in your project than you would invest in the bank to get the same future value out. Okay. Now let's just put this into our calculator. So let's just make some space quick so we can see the recipe, but we can also see the calculator so you can see what's going on. So we're just going to do that. And now we're going to look at how to input it into our calculator. So now we're going to clear all our data. So we're going to say CFI, second function CA, as well as second function CA. You can do it the other way around as well. It doesn't make a difference. Then we're going to enter our information. So the first piece of information we have is the minus 10,000. So minus 10,000, enter. And now we have 2 years of zero. So instead of entering them separately, because what if we had like 10 years of zero? We don't want to push zero enter 10 times. We will say 0. And then we're going to use our X, Y coordinate button. So X and Y button. And then we're going to say twice. So for 2 entries, it's going to be 0. That's what we're doing here. And we're just going to input it. Then for the third entry, it's 16,000. So 16, 2, 3, and enter. So now we've entered all our data points. Now we can go ahead and put in our annual effective interest rate or our nominal interest per annum compounded annually. And that is going to be 18%. So we're going to say second function cash, bring up the rate, enter it as 18, which is the I1 value, and push enter. Push down to get to net PV and push compute. And this gives us minus 261.91. Now, the negative PV says we're going to reject the project because we would have to invest an additional 261 Rand and 91 cents into the project. Okay, that's a bit. Go ahead